So typically when you wind up a clock, you actually take the power away from the escapement due to the winding process. So I'm investigating here an epicyclic gearbox or a planetary gearbox, which actually divides the torque between the winding and therefore raising the weight and some sort of maintaining power so that the clock keeps going. I think I'm going to incorporate this into my next clock, so I thought I'd make a 3D model to investigate it and see if it all worked. I also really like the idea of the differential barrel on which the weight hangs. This avoids a lot of reduction gearing and allows for a heavy weight falling a short distance. So one turn of the winder raises the weight by the difference between the two circumferences of the barrels divided by 2 because of the pulley. Here I'm testing to see if the system does actually work. So I've attached a spring balance to the annulus to simulate the load that would be applied to the clock, and I'm winding up the weight and seeing if the load exerted by the spring balance is actually varying. And it does actually vary by about 10 grams. The overall load applied is about 45. The next stage is to machine this out of aluminium, and I hope then I'll get a much tighter fit and a better working system.